In this tutorial I will show you how to use Stateflow.Simulink, okay, Simulink Stateflow block to model a simple chart. Okay, here I will take a simple half-wave rectifier circuit to demonstrate this. Okay, and this is our half-wave rectifier circuit. We'll model this in this tutorial from the beginning. Okay, this is our half-wave chart. Okay, and this is on and off. We have take some condition, and you can see the output or input is sinusoidal and our output is like rectifier output. Okay, and we used Stateflow, a fully Stateflow here. Okay, and so let's start from the very beginning, and I'm taking a new model here. Okay, for Stateflow we have to browse our library, and the Stateflow is present. You will find under this is our Stateflow. Okay, and this is the chart. Okay, we have to drag this to our model. Okay, this is our Stateflow chart, and double clicking on the chart will create a canvas like this. Okay, firstly we want a state. First state, this is our state. Okay, in Stateflow. Okay, and we have to rename it like I'm setting a name like on. Okay, and in on I'm setting our output y equals x, where x is our input. Okay, I will set input after time. Okay, and here this is our on state. Okay, and our output will be y equals 0. Okay, and this is okay, and we have to give transition from on to off, or off to on. Okay, sorry, it will be off. Okay, and from on to off I'm giving a transition like when our x is less than a threshold value t0. Okay, and from off to on when our x is greater than a threshold value t0. Okay, that's all we need. Okay, now for further going, we have to go modeling and symbol panel. Okay, and you can see our t0 is proposed to input data. Okay, but we need as a constant data, as this is a threshold value. Okay, and x is our input and y is our output. It's okay, and you can resolve all the undefined symbol here by clicking on this. Okay, you can see all the symbol are resolved, and we want t0 value is 0. Okay, and we have to back to our Simulink model by clicking our model name, and you can see our input and output is assigned. Okay, next we need a sine wave. Okay, because we want a sine wave to be rectified. Okay, and this is our sine wave, and then we need a scope. Sorry, this is our scope. Okay, and I'm setting sine wave here, and scope is here. Okay, now under sine wave I want frequency like 2 pi 100. It's 100 hertz frequency sine wave. Okay, I'm clicking OK, and under simulation stop time 0.1 is enough. Okay, and I'm setting stop inputs is 2. Okay, number of input is 2, and I'm taking layout is like this. Click OK, and this is our input sine wave. Okay, and I'm renaming it as input, and this is our output. Okay, now run this model. The cool thing of the Stateflow is that you can debug your model by using what's going on inside your code. Okay, and when you run this model, you can see the state is changing from left to right or right to left. Okay, according to the condition. Here you can easily see here, and this is our output data, and our input. We have to reduce our step size under modeling and model setting. under solver details and stepping max size 1e minus 4. Okay, now click OK and now run this simulation. Okay, now you can see this is our input and this is our output. Okay, you can also style our input and output as I have already shown you at the very beginning. This is gain and this is active display 2, and I'm changing it's S2, and this is okay. Now you can see this is our input and this is our rectifier output. Okay, and you can also tune your threshold value like 0.5 and so on to get the desired output. Okay, running this model again, as you can see, and back to Simulink, and you can see our output. Okay, this is look like this. So this is the simple way we can model Stateflow. Okay, and in this playlist I will show you more details in Stateflow. Okay, so that's all for today. Thanks for watching.